Hello everyone, welcome to the part 2 of linked list implementation in the data structure implementation series. So if you remember in the last video, we had created linked list, but we had not printed it and there was no way to print it because we had not written the code for it. Today in this video, we'll be printing the linked list. So there are multiple ways where we can print. One is via using loops in C++ and one is via using recursion. So first, we'll be going over the traversal via loop. So this is the typical structure of a linked list. And to print a linked list, the one thing that we require is the starting of the node. If you remember, we had stored the starting of the node in the head pointer. So we will be passing this head pointer to the function, and then we'll be printing the linked list. So here I have written the display function, which will be printing the linked list. And this is the iterative method. So here in the display function, we have stored the starting of the linked list in a temp pointer. And the same can also be seen on the screen as the temp variable is having the value of 100. That basically means it is a pointer and it is pointing to the first variable in the linked list. So now, because temp has value of 100, when the while loop hits, it is a valid number. Temp is having some valid address. Hence, we will go inside the while loop and we will print the data that temp is pointing to. So, since temp is pointing to the first node, temp of data is 10. So, in the output, 10 will be printed. Then, temp will be equal to temp of next, which basically means temp of next is 200 at the moment. So if we store 200 into the temp, then it will start pointing to the next pointer. And then again, we will hit the while loop condition, which is temp a valid address? Yes, it is a valid address. Hence, we will print temp of data. Now, since temp is pointing to the second node and it is having address of 200, we will print 20 as temp of data is 20. So in the next line, now temp is equal to temp of next. Temp is now pointing to the second node. Temp of next is 300. So now the temp will start pointing to the third node. And again, we will go to the condition of while loop. Since it is a valid address, then we will print 30 on the screen and temp has to go to the next value. So temp is equal to temp next. Now the temp will become null because temp of next was null. So now temp is null. When we check the while loop condition now, it will be null and null will break the while loop. Hence we will break out of the while loop and we will print null. So this is the output that we will get on the screen. I hope you understood the visual representation. Now let's jump into the VS Code and try to code it ourselves. So here, if you remember from the last lecture that we had created the linked list, but there was no way we can print the linked list on the screen. So for that, let's create a display function which will return void. It doesn't have to return anything. And this function will be accepting a variable of node type. Let's name it as temp. Now let's check if temp is valid. So if temp is valid, all we had to do was we had to print temp of data. And after that, we had to move the temp pointer to the next node. So temp should be equal to temp of next. After that, to print the linked list in proper fashion, I'll be also adding null so that it will have proper indentation when it gets printed. Now let's try to compile the code. So it is getting compiled. Let's execute it. Let's store 10, 20, 30. Let's break. Oh, I forgot to call the display function from the main function, and that is why it is not getting printed. So let's come here and add it in the main function. And we have to pass the head pointer here. So the head pointer will be passed to the display function, and the temp will store the value of head. So now let's recompile the code. Let's rerun it. 10, 20, 30, stop. So here, now the linked list is getting printed. So we got 10, 20, 30, and then finally we have null. Now we saw how we can print the linked list using loop. Now let's try to print the linked list using recursion. So this will not going to be a typical recursion video where I will be explaining you how recursion works, but I'll be going over the basics so that you can wrap your head around recursion and try to understand how it is being used for printing the linked list. So now here I've pasted the code for recursion. So basically the first and most important thing in recursion is to have a base case. So in the case of linked list, the base case would be we don't have a linked list. That is, the pointer that we get in the function is pointing to null. Hence, if you see the if statement that is written on the very top of the function is that if temp is null, then we are simply printing null and we are getting out of the function. So this is the base case. Then I am just printing the data in recursion and I'm trying to call the function again with the next pointer. So what this will do is it will print the value and it will move the pointer to the next node. And since recursion uses stack underneath, it makes our life even easier. So the temp is not null as of now. Hence, we will not go in the if block. And then we will print the temp data, which is temp is 100. So 100 of data is 10. So we will print that on the screen. Then we will call the function display with temp of next. So when we do this, temp will now have the value of temp of next. So temp of next is 200. So now temp will be having the value of 200. Now we'll check the if statement, which is not true again. So we will now print the temp of data. Since temp is 200, 200 block data is 20. We'll print that and we will again call the display function with temp of next. So again, we will move the temp to the next node and if block will not be executed as temp is not null. So we'll print the data of temp, which is 30. Then we will again call the display function with temp of next. Now the temp of next is null. So finally, now the if block will be hit as temp is now null. So we will see out the null and we will return from the function. Now let's try to code this and implement this ourselves using recursion. So here we already have one display function, which is printing the linked list using while loop. Now I will comment this and I will create another function with the same name, display. It will get a pointer, which is head. And now I'll write the recursive code. So first thing was we had to write a base case. So the base case is very simple. If I don't have a linked list, so that means I don't have anything in the temp, which is I'll be having null. In this scenario, I have to see out null and I have to simply return because I don't have anything. Now I just have to print temp of data. And simply I have to call the display function with temp of next. So basically what we are doing is we are doing two things. We are printing the data at that node and then we are moving the pointer to the next node. Because we have already called the display function, so this function will already be triggered. Let's try to compile this and run the code. So let's recompile the code and rerun it. 10, 20, 30, 40, 50. Stop. So now you can see that the linked list is printing the contents via recursion. Now let's try to print the reverse of the linked list. So to do that, it is very simple. Now that we have already written the recursive code for it, all we have to do is we have to swap the last two lines in the recursive code that we had written. So earlier, cout was above and display was below. Now display is above and cout statement is below. So the display function that I have written, it gets the head. And so basically for any recursive code, we have the base case, which remains the same as the previous code. Then we are calling the display function with temp of next. And when we return, we are printing the data. So this will help us print the data in reverse order. Because recursion internally uses stack, here I will be showing an example of how it is utilizing stack. Now I will be covering up stack in a future video thoroughly, but to help you wrap your head around how stack is being used in recursion and for printing linked list, I'll be showing you a small demo here. So in the stack, you can see that we have the main function call, and then on top of it, we have temp as 100, which is being stored. So that is nothing but the top of the stack is basically the display function that is being called, and the variable I have stored it in the stack. As there was not much space to show the display function as well there, I have only showed the value of temp. But the top of the stack at the moment is nothing but the display function call that is made. So now let's go over the code. So temp is now pointing to the first node in the linked list, the address of which is 100. So the if block will not be executed as temp is not null. Finally, we call the display function with temp of next. So now what this will do is it will move the pointer to the next node, and also on the stack we have added another temp with value of 200, that is address 200. Now this new stack which is added at the top is nothing but display function being called again, and that variable that is there I have shown in the stack, but that function display is called again. So temp is not null. Again, we will call the display function with temp of next. So the temp pointer will move. And again, on the stack, we have added temp is equal to 300. As temp is not null, we will again be calling the display function with temp of next. Now, finally, the temp becomes null, and the same value is stored in the stack as well. Now the if block will be executed as temp is null. So we will be printing null and we will return out of the function. So when we return out of the function, the topmost element has to be popped. So the topmost element is popped and the return will come back to the display function. Finally, now we will be executing the cout statement and we'll be printing the temp of data. Now in stack, we always operate on the topmost element of the stack. Hence, at the moment, the topmost element is having the value of 300. That is, we are pointing to the last node. Temp of data will be 30. That will be printed on the screen. So since temp is pointing to 300, we will be printing 30. And then we will pop this element because the function ends. Finally, now the top of the stack is 200. We will have our control back to the display because we returned earlier because the function ended, right? So if there is no return mentioned in the end of the function, then there is an implicit return already written by the compiler. So the flow will come back to this display function, which is of 200. Then we will print the temp of data. So temp at the moment is 200. So 200 of data is 20. So after 30, we will be printing 20. And then we go to the end of the function and we will pop the topmost element. Then since we popped that, then the temp of data will be printed. So temp is 100, 100 of data is 10. So after 30, 20, 10 will be printed. And finally, the topmost element again will be popped since the function has completed. And then finally, the flow will go back to the main function. And when the main function return 0 is called, then finally the main function also gets popped from the stack. So this is how stack works. So let's try to implement this and see this in code. So as I mentioned earlier, that we just have to swap these two lines of code. So instead of rewriting everything, we can just swap them. And now since you understand how it will be printing the data in reverse, let's try to compile and run the code. So let's recompile, rerun it. 10, 20, 30, 40. Let's stop it. So now you can see that 40, 30, 20, 10, the linked list is printed in reverse order. Now just ignore the null that is printed here. That is because we wanted proper formatting of the linked list. And since we are printing it in reverse, it actually doesn't matter. You can try to fix this. You should take this as a task, and you should be printing null in the very end. So you can take that up as a task. We were successfully able to print the linked list using while loop, using recursion, and then we printed the reverse using recursion as well. So that is it for the video. Probably in the next video, I'll be covering how to find the size of the linked list. And in the coming videos, we'll also be looking into how we can actually reverse the linked list. Instead of just printing the data, we will actually be able to reverse the linked list. If you like the content that I create, make sure to like, share, and subscribe. And I will see you in the next one.